Hello student, I am Mayur Gondalia and you are watching School of Physics. Student, today we will learn about Fourier series of a sawtooth wave function. Fourier series of a sawtooth wave signal. The nature of the sawtooth wave signal is like this. It is defined as f of x equal to x for minus pi less than x less than pi. From the nature of the wave signal, we say that it is an odd function. It is also found from the expression of the wave function that it is an odd function. Yet, if you can't decide about it, then follow this process. F of x equal to x for minus pi less than x less than pi, say equation 1. Take x equal to minus x. Therefore, f of minus x equal to minus x for minus pi less than minus x less than pi. We put negative sign with all x. Now we replace less than sign by greater than sign in this interval. That's why we have to change signs of minus pi, pi and x. Therefore, f of minus x equal to minus x for pi greater than x greater than minus pi. Now, rewriting the interval in inverse order, we have f of minus x equal to minus x for minus pi less than x less than pi, say equation 2. In this equation, fx equal to x, while in this equation, f of minus x equal to minus x. It means f of x equal to minus f of minus x. Therefore, given function is odd. As fx is odd, therefore coefficients a0 and an are 0. Now we will calculate bn. Bn equal to 1 upon pi integral minus pi to pi f of x sin nx dx, and which is equal to 1 upon pi integral minus pi to pi x sin nx dx. Here the value of fx is x. Now this is odd and this is also odd. Therefore, integration of odd into odd, that is integration of even. So, by applying property of even function, we have bn equal to 2 upon pi integral 0 to pi x sin nx dx. We will simplify it using formula of integration by parts. The formula is integral u v dx equal to u v1 minus u dash v2, where u dash equal to du by dx and v1 equal to integral v dx and v2 equal to integral v1 dx. In our expression, x equal to u and sin nx equal to v. Therefore, bn equal to 2 upon pi into bracket x minus cos nx upon n limit 0 to pi minus 1 into bracket minus sin nx upon n square limit 0 to pi. Here u, that is x, so here we put x. v1, that is integration of sin nx, so here we put minus cos nx upon n minus u dash, that is differentiation of x, so which is 1. So here we put 1 into bracket v2, that is integration of v1, that is integration of minus cos nx upon n. It is minus sin nx upon n square. Now, putting the value of limits bn equal to 2 upon pi into bracket minus pi cos n pi plus 0 upon n plus sin n pi minus sin 0 upon n square. In these terms, sin n pi equal to 0 and sin 0 equal to 0. Therefore, bn equal to 2 upon pi into bracket minus pi cos n pi upon n. This pi and this pi cancelled and take negative sign out of the bracket. Therefore, bn equal to minus 2 upon n into bracket cos n pi. And now Fourier series is f of x equal to a0 by 2 plus summation n equal to 1 to infinity an cos nx plus summation n equal to 1 to infinity bn sin nx. Putting the value of coefficients, we have f of x equal to summation n equal to 1 to infinity minus 2 upon n cos n pi into sin nx, which is equal to, now take this minus 2 out of the summation sign. Therefore, f of x equal to minus 2 summation n equal to 1 to infinity cos n pi into sin nx upon n. Expanding it by taking n equal to 1 to 3 so on, we get f of x equal to minus 2 into bracket minus sin x upon 1 plus sin 2x upon 2 minus sin 3x upon 3 plus so on. Readjust this negative sign with the sign of the terms into the bracket. So f of x equal to 2 into bracket sin x minus sin 2x upon 2 plus sin 3x upon 3 minus so on. This is the Fourier series of sawtooth wave function. In next video, we will learn about some problems of Fourier series. Please write your suggestion in comment box, like and share this video, and subscribe my YouTube channel, School of Physics. Thanks.